Hey Shannon, so I'm looking at these pages that you sent to me that your friend is struggling with, and I want to go over this with you so you can share it with her. Um, when I first taught this to you guys, if you remember in math, and really it doesn't matter which way you do this because you're going to get the same answer either way. Um, but if your friend's instructor is kind of making her do the dimensional analysis, I'll show you how I do the dimensional analysis too. The way that I teach this, I use a formula called D over H times Q, which stands for dosage ordered or doctor's order is D. H is the dose we have on hand, and Q is the quantity on hand. So oftentimes H and Q are always listed together because that tells you what we have per a certain amount. So, like in the first example, number one, it says available is 500 milligrams per tablet. Looking right there at that spot, 500 milligrams per tablet, that's your H and your Q. It's 500 milligrams as your H per one tablet is your Q. So when I teach this, you take the order dose, which is 1 gram, divided by the dose on hand per the quantity of one tablet. Now, when I teach it, I tell everybody that you need to make sure D and H are the same unit because what you want to happen is you want those units to cancel out. You want them to be the same so they cancel out, leaving you with the unit tabs because that's what we want our answer to be. We want to know how many tablets will we give this person. So I teach in order to convert grams and milligrams. I teach that you can just convert those grams into milligrams, and then therefore they'd be the same. Now I teach metrics two different ways, and I've also sent those two videos for metrics to you, Shannon. I'm gonna include it in the email that I send with this video, so you can send that to your friend. However, another way to do it, and the way again that I'm going to show with the dimensional analysis, is that with dimensional analysis, her instructor may be having her remember that there are 1,000 milligrams in every 1 gram. So if you just have 1 gram, we know that that's the same thing as 1,000 milligrams. So the way that I teach it is to do it this way, to use this formula. And so now that they're the same, what happens is the unit milligram, since they're the same, they'll cancel out. In this process, the numbers don't. We would just take 1,000 divided by 500, which is 2, and then times 1 tablet. That's the unit I'm left with, so my answer would be to give 2 tablets. I'll also include my dosage calculation videos that goes over using this formula. But in this video, what I'm going to do is I'm going to show you how that dimensional analysis works and how we can get the same answer using dimensional analysis. This is just showing you how I teach that. And like I said, I'll show you that on a separate video. And Shannon, that might be familiar to you, and we'll do that. We did that in the LPN math, and we're going to do it again in the RN math towards the end of the quarter. But let me show you what I do with dimensional analysis. I set it up a little bit differently than the way the textbook does here. What I do is this, when I was first taught dimensional analysis, I was always taught that you just take what's been ordered. We've got 1 gram has been ordered. So what you're going to do is you're going to multiply it. Now I'm just used to using parentheses to show multiplication. So, and I use it as a fraction. I multiply by, and that's going to probably run out of room here. So let me write that a little bit smaller. So that we take what we have, what we start with, and we multiply it by these knowns, by these conversions that, okay, so 1 gram. Well, this medication comes 500 milligrams per tablet. So we know right off the bat that we're going to have to convert this to milligrams. So maybe right off the bat we can multiply that by the fact that there are 1,000 milligrams in every 1 gram. Right away, just this multiplication problem right here, just like we do in the D over H times Q formula, the units, when they're opposite numerator denominator, will still cancel out, meaning right now, I know that the doctor's order, being in 1 gram, 1 times 1,000 in this multiplication problem is the same thing as 1,000 milligrams. Now, we need to figure out how many tablets we're going to give. So, if we multiply by our, what's available, the fact that there is one, and notice that I'm setting it up where opposite numerator denominators will cancel out. That's how I always think about that I want, my answer, the unit that I want is on top, that I'm trying to convert it to is on top, and the unit that I'm trying to cancel out is on the bottom. So right now, milligrams and milligrams being opposite of one another will now cancel out, meaning my answer will be in tablets. So in dimensional analysis, you simply just look at this as one multiplication going straight across, that we take 1 gram times 1,000 times 1 at the top, which leaves us with 1,000. And then at the bottom, so kind of looking at it as a denominator, there's nothing in the denominator here, so we can almost think of it as 1. So it's like 1 times 500 leaves us at the bottom with 500. And just like we had in that D over H times Q formula, we just take 1,000 divided by 500, and my answer would be 2. And again, it's tablets because that was the unit I was left with. It did not cancel out. So that's how I got that 2 tablets. And I'll show you doing the same thing on the next problem, how I do that dimensional analysis, and and I'll not put it in parentheses this time. I'll kind of do what they're doing. So in this problem, we've ordered medication Y, 30 milligrams by mouth daily. You have available 20 milligrams per 5 milliliters. Again, using the dosage formula, that would have just been 30 milligrams divided by 20 milligrams times 5 is how we would do this. But again, using dimensional analysis, we'll get the same answer if we do it that way. How I do it is I take what's been ordered. So here's what I start with, the 30 milligrams. And I show that, again, when we're multiplying by the known, what's available, there are 5, for every 5 milliliters, there are 20 milligrams. Milligrams. That means that what's going to happen in this problem, again, milligrams and milligrams will cancel out, leaving me with how many milliliters I'm going to end up giving this patient. So multiplying straight across would be 30 times 5, which is going to give us 150 milliliters. Well, it doesn't have to be milliliters, it's just the numbers we have on top, but my answer is going to be in milliliters since that's what I have left. But it's 150 at the top and then 1 times 20 at the bottom. So we would take 150 divided by 20, which is going to give us 7.5 milliliters. So that's how I get that answer. They're doing it just by, it looks like they're just taking, they're just showing the known first, what's available, and multiplying it then by what's been ordered. So it's kind of the opposite, but how I was, it's just how I kind of look at it is just take what I have, here's what's been ordered, and based on the information that I have in front of me, how can I get it to what I need to give this patient? So what's been ordered, let's see, on number 3, the third one there, it looks like we're looking at a drops per minute situation. With drops per minute, Shannon, again, I taught a formula to you guys. It was just easier to remember the formula, which says to take your volume divided by your time, but your time needs to be in minutes, and then multiply it by the drop factor. So in this question, we would end up just taking 1,000 milliliters. It says every 8 hours. I guess that means over 8 hours. So I mean 8 hours times 60. So I taught you guys to just take the hours and multiply by 60 to see what that would be in minutes. So you would end up taking 1,000 divided by 480 minutes and then multiplying it by 10, and you'd end up getting the same answer using the formula. Now, using dimensional analysis, they just show all those conversions all at once. So taking what you have, if we set it up the way that I think of it, 1,000 milliliters, okay, we need to, figure out what we're giving in terms of drops per minute. So I don't want milliliters, so I look at it as our drop factor is 10 drops per milliliter. So 10 drops per milliliter, per 1 milliliter. And that, again, right there will cancel out those milliliters and leave me with drops. At the first part there that I'm gonna go ahead and just cancel that out, and it's got the drops part of it now. Now I need it to be in drops per minute. Well, we were ordered to give it every 8 hours. So we were ordered to give 1,000 milliliters over 8 hours. Trying to think of how they... Yeah, they just do it a little bit differently. So I'm trying to kind of think of it as I go here. So, okay, so they've already done it this way. So 1,000 milliliters, we can already set that up as how they showed it over 8 hours. So that's kind of what's been ordered, 1,000 milliliters. So I left that part out of the what's been ordered already. So far, since we've canceled out milliliters, right now we have drops per hour is a way to look at what we have at this point. We need it to be drops per minute. So that's where that second conversion factor comes in. The fact that every 1 hour is 60 minutes. Well, that right there will cancel out those hours, and now I'm left with drops per minute. So we can look at it that way. So the whole problem going straight across, 1,000 times 10 is 10,000, and then 8 times 60 is 480. So 10,000 at the top divided by 480 is what we're left with, and that will give us our answer of 21.83. And then drops are typically rounded. Whoops, that's a point. Drops are typically rounded to the nearest whole number. Typically you round, what they're doing in that is you don't want to round up because you don't want to give too much medication depending on what it is. So typically it's just rounded to what's in front of the decimal. So even though 21 isn't technically correctly rounded to the nearest whole number, 21.8 would round to 22, but in drops, sometimes it's just rounded to the whole number that's in front so that you don't end up giving too much. Okay, so that's what we end up getting on that one. So I hope that helps, that you start with what's been ordered, and then you use the different conversions that you have, and you multiply by those, thinking about how you can cancel out along the way. And again, to cancel out, it needs to be opposite numerator denominator. It doesn't matter where in the problem they are, that's opposite numerator denominator. As you saw with our hours, notice that the denominator was over here, and over here those hours still canceled out because they were still, one was in the numerator and one was in the denominator. Even though milliliters and milliliters were right next to each other, that doesn't always have to be the case. I very well could have put my 1 hour and 60 minutes first to cancel out the hours, and then the 10 drops over 1 milliliter next, and the milliliters still would have canceled out, and it still would have given us the same answer because we still would have ended up with 10,000 divided by 480. All right, so just looking at the last one there, it shows us an IV antibiotic is to infuse in 30 minutes 4 times daily. We have available 50 milliliters of antibiotic. How many milliliters per hour would you set the flow rate? Okay, so again, and I'll include these videos too to show you how I typically teach IV flow rates, because again, I teach using formulas, so I think, in order to find milliliters per hour, you just take the milliliters and divide it by hours. So we would take 50 milliliters divided by the fact that we're giving it over 30 minutes. Again, right there is milliliters per minute, so we would have to convert the minutes to hours. So it'd be 50 milliliters, 30 minutes we know is half an hour, so 30 divided by 0.5 would give us 100. Now, so that's just using a formula. But using the dimensional analysis, think, okay, well, we have 50 milliliters, to give over 30 minutes. So 50 milliliters to give over 30 minutes is what we have right now. Well, our conversion for, again, to get that to hours is every 1 hour. Oh, I'm sorry. I got to cancel out the units. So again, there are 60 minutes in every 1 hour. So that, again, I set it up that way so that minutes and minutes could cancel out, so that when I multiply at the top, I have, again, I'm going to be left with now is milliliters per hour, and that's what I'm looking for. So I can go ahead and multiply straight across. 50 times 60 would be 300. Down at the bottom, 30 times 1 is 30, and 300 divided by 30 would be, did I do that right? Yeah, would be 100. Okay, I'm having a brain fart today. Okay, so I hope that helps with that page, with using that dimensional page. When I showed you guys this, I hope that helps with the dimensional. On the second page that you sent me, these were using a lot of, it looks like the metric conversions. So I included those metric conversion videos, so I hope that helps with how I teach that. Because it just shows the, how it moves, like in number 1, the number of decimal places. So milligram to gram conversion would be 3 places. The recommended way to write large numbers in the metric system, for ease of reading as in 100,000 micrograms, I guess would just be the more correct way to write it would be letter A, just how we write, because with decimal points, B would be totally incorrect because 100 with a decimal and then 3 zeros would just be 100, so that would be wrong. With spaces, that's not how you write numbers. Without spaces or inserts, this would be correct too, because you don't have to use commas, but I would guess A on that one because it helps to separate the place values. I might have to look into that and see if there's a certain way that those are supposed to be written in the metric system. I would assume with commas would be correct. 25,000 micrograms to grams. Micrograms to grams would be 6 places to the left. Or in the other video, I teach that you can use the stair-step method, which says to divide by 1,000 to get to milligrams, divide by another 1,000 to get to grams. So we would end up dividing by 1,000 twice, which would end up getting us letter D. Let's see. So before doing all these metric conversions for you guys, number 4, the SDR for 10 to 30. So for this is a safe dose range, and I can, again, include a different video on this, and I'll call it safe dose range. But 10 to 30 milligrams per kilogram per day, this is a safe dose range that's just kind of safe for every patient. This is just what's on the label of that medication. So when it says milligrams per kilogram, that means we're going to have to incorporate our patient's weight to see exactly what our patient can take. So specifically, we have a patient who is 44 pounds. So 44, when we take that and divide by 2.2, what does that give us, 20? So yes, that means that our patient is 20, oh, whoops, I didn't mean to switch the marker there. That means our patient is 20 kilograms. So what we do for safe dose range is we can figure out our minimum dose and our maximum dose specifically for our patient by taking our patient's kilogram weight and multiplying it by both sides of this range to see what's safe for them. So let me get this out of the way. We already see how we converted to pounds to kilograms is always divided by 2.2. So when I take that weight and multiply 20 times 100, 20 times 10, is 200 milligrams on the low end. On the high end, 20 times 30 is 600 milligrams. So safely, my patient can take 200 to 600 milligrams per day, not per kilogram per day. We eliminated the per kilogram when we when we multiplied that weight. So now we've got it to where it's just milligrams per day. So that's how we can see what my patient can safely take. So that would be letter D on that one. Let's see. Select the appropriate measuring device and volumes when preparing an oral medication. Sorry, I need to get that out of the way. Oral medication of 24 milliliters to be administered in a 30 milliliter calibrated medicine cup. Pour 20. Well, that seems like a lot of work. Pour 25 milliliters in the measuring cup and remove 1 milliliter. That seems silly. Pour 20 milliliters in the measuring cup and then administer 4 milliliters with a 3 milliliter syringe. I'm going to guess it's letter C. Pour when using a measuring cup, you just pour it to the 24 milliliter line, just short of the 25 milliliter line. Again, I know the math part of it. I don't know the specifics of, maybe the nursing part of it, but I would guess that would be the more appropriate way to do that. Number 6 is another metric conversion. Again, I'll show you guys, I'll show a separate video on that before just doing all the work on these. Catching measure calculation errors. Most important safety nets, I would assume a calculator. That would be pretty important. Of those conversions, we have more metrics, and it looks like the last 3 are the metrics. So I'll send a separate video on the metrics so that you guys can have that as well. So I hope that helps at least with the dimensional analysis that we had on the previous question, on the previous And then on this page, I hope that helps. I know that most of these are all just metric conversion. So again, I'll have a separate video on that to show you guys how I cover metrics. And then with the safe dose range, what we did there on number 4. I hope that helps with that, and I'll send a separate video on that. So I hope that helps. You guys let me know if you guys have any more questions.